Hi, everybody. In this episode, we're going to talk about crystals. We all know crystals from our salt, and it's a bit difficult to see, but they are pretty large, these crystals. Uh, but uh, do we also have crystals in metals? Yeah, we do. Uh, Sometimes they are so small you're not able to see them. Then you need a microscope. Uh, if you look into the microstructure, you can see very tiny, small crystals. And on the edge of them, between them, you have the borders. And you can see how the grain they grow, and when they meet, there's some they meet from different sides, so they do not grow properly together. So there are some errors in the crystal structure in this border region, and that we'll come back to what that can do. One of the things it can do is that it can enhance the property of a material. The more grain you have, the smaller grain, the more boundaries, the higher strength you typically have. That is called the Hall-Petch relation. So the smaller grains, the higher strength. Then you could also have materials where the grains are so big that you can see them with your eye. You can see from my garden some examples where I was out yesterday and taking some video of it. And if you look here at the mailbox, you can see the grains are very large. So I will challenge you, if you can find grains larger than these, I will post them on my LinkedIn profile. But do we have even larger grains? And can you use something with even bigger grains than those you see on my mailbox? Yes, you can. There are areas where single crystals are used. It's known for wafers. So when you make silicium, you grow a single crystal out of the silicium bath. That is important because when you want to make these very small wafer products, you need them to be perfectly uniform, and therefore you want to cut it out of a single crystal. But is it also something that is used in the world of metals? If you think of this Hall-Petch relation, where the larger the grain, the lower are the mechanical properties or the strength. Yes, there are. For some applications where the grains can be the reason for degradation over time, then it is an advantage if you can avoid these grains. So if you look at this, a turbine in a jet, in here temperature can be very high. You can have temperatures around 800, 900 degrees C. And at these temperatures, the grain, they can start to move. And when they move, the material properties, they change. You can even have mechanical movement of the structure. So it's not stable when you have it at high temperature. This phenomenon is called creep. And to avoid creep, turbine blades like these in an airplane, they are produced with single crystal material. How they do that is extremely advanced. I would encourage you to look deeper and see on YouTube if you can find some videos where they show how they produce it, because it is very amazing, and it gives you some insight in why are these motors so expensive. Uh, but what is this creep? You might not have heard of it, but creep is a phenomenon that occurs everywhere where you have elevated temperatures. And I have invited Professor John Hald from the Danish Technical University to talk about it, because he has been working with creep of material typically around 600 plus degrees C for many years. And he would like to tell something about how can you mitigate it, how can you live with it, how can you design with it, because not all material can be made in single crystal. Far majority of materials are made in multi-crystal, and you have the grain boundaries you have to handle. But there are some tricks. You can add some alloying elements. You can do something to it. You can design you out of it. And John, he will tell about that in an upcoming episode. So if you have any questions on creep you would like me to forward to John, please write them below in the comments. It will be fantastic, and I will gladly forward them, and then we can learn all together. So thank you very much. Oh, I forgot to mention that if you like content like this and if you want to learn more, to subscribe to this channel will be a good idea, because that gives us some insight in that what we do is what you would like to see. So please subscribe and tell us by that this is content that we should continue doing. Thank you.